Alright, the next question is June 08 paper 1. A student is carrying out an investigation on the properties of shadows. She places an opaque object between a point source of light and a screen. So there's your opaque object there, and there's the source of light and the screen. A point source of light is a very small source of light. So already that should be indicating to you something about the shadow being an umbra shadow or a very sharp shadow. So we'll see the rest of the question. The student keeps an opaque object at the same distance from the light source throughout her investigation. She moves the screen further from the opaque object, so she's moving the screen to different distances. And for different distances, values of distance d, she measures the height of the shadow h. The following results are obtained. So there's in your box or in your table there, you've got distances d, and it ranges from 20 up to 60 centimetres, and then the height of the shadow is this height here, and the height of the shadow ranges from 8 up to 14 centimetres. Plot the results on the grid below and draw a straight line of best fit. Extend the line of fit so it crosses the vertical axis. So they're warning you there that it's not through the origin. I'm just going to write that in there. So read your question carefully, not through origin. Very often when we draw a line of best fit we put it through the origin, but this one we're being told it's not. It's going to cross over here somewhere. So the next thing you have to do is then plot your lines. So the first one there is 20 centimetres and 8. Make it fairly definite, an X with a dot round it, or given that my pen's quite wide here, I'm just going to make a dot with a circle around it. Next one is 30 and it's 10, which is this one here. The next one is 40 and it is 12. The next one is 50 and it is 14. And the last one is 60 and it is 11. Now 11 is down here, so it obviously looks like there's something wrong with 11 and possibly a wrong point which we are going to ignore. So that's an anomalous result, and whenever we draw a line through these, our best fit line, you can see it's a perfect straight line which passes through around 4 centimetres there on the y-axis. So that's where it crosses the vertical axis there at the 4. So the next question says which value of h in the table was incorrect, and you can see very clearly here that this value here is incorrect. You don't have to write it on, you just have to write it down in your answer in the next page. And this is really why we would plot a graph, because very often we can see an anomalous result much more clearly than we can see from a table. Unless you're going to do some work with the numbers and see how much they increase by and so on. It's much easier to see that when you plot it onto a graph. So the answer then is that the 60 centimetres, and it's got a height of 11. I'm just going to write in there 60, 11. Use the graph to find out the height of the opaque object. So the height of the shadow is going to be where it is, the screen is no distance away. And the screen is no distance away, we're getting the actual height of the object. So if we go to the screen being no distance away, that's where it crosses the axis. So the answer is going to be, sorry you can't see that, I'll do that again. You can see that whenever the screen is no distance away, over here, it crosses the axis there. So that must be the height of the object itself, which is going to be 4 centimetres. Okay, so this time the student then places an opaque object between an extended source of light and a screen. On the diagram above, draw 4 rays of light to show the formation of the regions of total shadow, the umbra shadow, and then the partial shadow on the screen. So if you remember with an opaque object, and I think I'll do this in pen rather than marker, that whenever you have an extended source of light, you have to draw a ray from the top of the light source over the top of the object, like that, and put an arrow on it, and a ray from the top of the light source under the bottom of the object, and it's something like that there. And then do exactly the same from the bottom of the source of light. You're going to draw a ray from the bottom of the source of light over the top of the object and put an arrow on it. And an arrow from, or a line from the bottom of the object of the light source across the bottom of the object, like that. Now you can see on the screen then you've got a region of total shadow and a region of partial shadow. And it says there then, shade the region of total shadow. So we're just going to shade this region here. And you can write umbra behind it, or total shadow. Hopefully you can see that okay. Okay, so just the marks on this, you would have got a half mark for each line, and you round them up then. So if you had got 3 of them right and 1 of them wrong, you still would have got 2 marks here. The region of total shadow, or the umbra, is uniformly dark, but the region of partial shadow, the penumbra, gets brighter as its distance from the umbra increases. So in other words, it gets brighter the further out that it goes. In what other way is the umbra different from the penumbra? So the umbra is much sharper. And it's also a very black shadow. But the penumbra, so again it's asking you to list a difference. So mention both of them. The penumbra is hazy. And it's a grey colour. And that's enough to get you your 1 mark. So they're really looking for the idea that you understand the bit about being hazy, the penumbra being hazy. Next question. In what way, if at all, just move this down for you. In what way, if at all, does the size of the umbra change when the source of light moves closer to the opaque object? Assume the white screen remains in place as before. Now, if you weren't sure about that, it's a really good idea. I'm just going to go back to this again. And I'm going to draw over the top of it, even though I wouldn't do this in an exam. But if you had a pencil and you had a wee look at this and saw where, if you moved your light source closer, where would the light be coming from? So say I move it closer and move it closer, the light would be coming from, say, these 2 points here. And if I drew, I'm going to draw these in red. If I draw my 4 lines again, you'll be able to see what happens. There's 1 there, and 1 there. And then the second set of lines there are from here and here. So this is if I had moved my light, there's my light source there, if I had moved it closer. Now you can see a big difference there. You can see that both the umbra and the penumbra are much, much bigger. So that's a good way of doing that. Draw it in pencil and rub it out again if you have to, or even try and imagine what happens if you move your light source a little bit closer. And so the answer then is that it increases in size.